All right, kiddos, welcome back. This is station number 2. And the first thing I want to do is I want to review what those 4 main properties of water are. So let's revisit our whiteboard. The 4 properties of water is it sticks to itself, also known as cohesion. Number 2, it sticks to other substances, also known as adhesion. Number 3, it can absorb large amounts of energy. And number 4, it dissolves many things. Now, if you recall in station 1, we demonstrated it dissolved many things. The oil would not dissolve the salt, whereas the water did dissolve the salt, which makes it a universal solvent. All right, on to station number 2. The station number 2 is very simple in the materials it requires to complete. We're going to use a penny, a paper towel, some water, and a pipette. Okay, and what we're going to do is we're going to see how many drops we can get on top of this penny of water before it bursts over and wets the paper towel. Now we're going to try this lab 3 times. I want you to think in your head right now, why might we try this same experiment 3 times? What you should be thinking about right now or saying out loud is, it's more accurate. The more trials you have, the more accurate your data is. So we're going to do 3 trials, and then you're going to find the average. You'll find the average by adding up all the number of drops and then dividing by 3. Okay? All right, let's get started. Let's see. I'm going to zoom you in here so you can see a little bit better for the penny. And let's see how many it can get. And I'm going to stop. Hopefully we can get to 20 or 10 rather, and I'm going to stop and show you the bubble so you guys can kind of see how this cohesion idea works. So let's get started. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, I'm going to zoom you in. Hopefully you can see that perfect bubble of water right on top of the penny. That is the idea of cohesion, or water sticking to itself. Pretty cool. All right, we were at 10. Onward. 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. Ooh, and we burst over. 26 for trial 1. I'm going to go ahead and erase this whiteboard here, and I will jot the data down so you guys can have it. So trial 1 with water was 26 when it burst. So I'm going to show this to you. Trial 1, 26 when it burst. All right, let's work on trial 2. I'm going to have to move it to a fresh part of the paper towel so we know when it goes. All right. All right, and I'm going to reset my pipette, and this is trial 2 of plain water on top of the penny. All right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. Ooh, and we burst over at 23. Again, going to jot that down on my whiteboard here. Trial 2 equals 23. Whoops. You can't see that? Here we go. Trial 2, 23 drops. All right, last one, trial 3. Again, we're going to wipe off the penny a little bit here. And I'm going to flip it and rip it a little bit so I have no water on it, and then I know when it burst. All right. And here's my nice dry penny, resetting my pipette. And this is trial 3. 1, 2, 3, 4, 5, 6, 7, 8, 9. Ooh, we burst at 9. Now that could have just been some some inaccuracy of the lab because I kind of touched the edge of my pipette to the bubble, which made the bubble burst a little faster. But that's why we do 3 trials, so that if you get kind of an outlier like that, it still will reflect accurate data. So trial 3 is at 9. All right, don't forget you have to find the average of this by adding these 3 numbers up and then dividing by 3. All right, the next one we're going to do is we're going to do water with soap. And we're going to see how the soap changes the cohesion of the water. All right, so we are on to part 2 of station 2, where we're going to test a soap water solution on the cohesion of water. And we'll see how many drops a penny can hold based on this soap and water solution. So I'm going to take my just plain water in my beaker, and I'm going to add some Dawn soap. And then I'm going to make sure it's nice and mixed in. It should be plenty. I'm going to use my fork here and I'm going to stir it up. Nice and soapy. Might even put a little bit more. Make sure we got a good amount of soap. Oh yes, perfect. All right. Awesome. Now we have a soap water solution. So this will go into the second part of the data table. Again, I'm going to take my pipette, I'm going to squeeze it and let it fill up with soapy water. And we'll see how many drops the penny can hold of soap water. So, trial 1. 1, 2, 3, 4, 5, 6, 7, 8, 9. Ooh, we burst at 9. So, what you're going to be able to tell about the soap water solution is that it's not going to be able to hold as much because the soap breaks the cohesion of water. So the soap solution for trial 1, we got 9 drops. Should be looking like this on your data table. All right, let's do trial 2. Make sure we stay consistent. Again, I'm going to wipe off my penny, get it nice and dry, and bring it to a new part of the paper towel that's not getting wet yet. And I'm going to refill my pipette. And trial 2, here we go. 1, 2, 3, 4, 5, 6. Ooh, we burst at 6. All right, trial 2 is 6. So T2 equals 6. Again, significant difference from just the regular water to the soap water. The soap water can only hold 9 or 6. Whereas the water could hold 26 or 23, and the lowest it got was 9. All right, last trial, trial 3. Again, gonna find myself a clean part of the paper towel, and I will do my last trial. Fill my pipette up here, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Ooh, no, not quite. 12. There it goes. I thought it was close. All right, that one was 12. That was actually our best trial. So for T3, it's 12. And I'm going to give you guys one more look at all this data so you guys can make sure you write it down in your own data tables. All right. So trial 1 for, trial 1 for water over here. Trial 1, 2, and 3 for soap and water solution over there. All right? Perfect. So make sure you put this in your data table and also find the average. I'll remind you one more time how you find the average is you add up the numbers and you'll divide by 3 since we did 3 trials. And that'll give you the average number of drops that the soap can hold and the average number of drops that the water can hold. Okay? Let's take a step backwards and think about those 4 properties of water. Which one did we demonstrate in this lab? It sticks to itself, it sticks to other substances, it absorbs large amounts of energy, or it dissolves many things. We know it didn't dissolve anything. It didn't stick to anything else. It stuck to itself on top of the penny, and it didn't absorb any amount of heat. So we're left with the idea of cohesion. It is property number 1, which is it sticks to itself. The soap will break the cohesion of water, which will cause those molecules not to stay together as well as when it's just water by itself. All right, see you guys for station 3.